Hello, everybody, and welcome to the Simply ICS Cyber podcast, a new podcast featuring myself, Don C. Weber, as the cybersecurity guy, and Thomas VanNorman as the OT guy. So, Thomas, why don't you help people by introducing yourself? This is a new crowd to us. So,
Absolutely. Thank you very much, Don. Welcome, everyone. My name is Tom VanNorman. I'm the ICS guy on this podcast that Don and I are starting. This is season one, so thank you, everyone, for joining in. Don, a little bit about myself. I got started with working in industrial control systems just about 3 decades ago. Over that time, I've filled many different roles, from engineering technician roles, working with the different types of industrial control systems, transmitters, processes, field devices, all that stuff, and all the way to security, where I am today. How about you, Don? How did you get into this?
well, I have never worked on the OT side outside of doing cybersecurity for it. I got into cybersecurity out of the Marine Corps. I knew I wanted to do that as a part of a computer career. And then around the 2010 timeframe, somebody asked me to start hacking smart meters. So I had to learn hardware hacking, which helped me understand the endpoint devices, the devices that are actually connecting to the process, controlling the physical world, the communications back to the back end. So it's just been since 2010, I've gone in and out of the industry doing that. So it's been pretty cool. Tom, it's one of the things I don't think that the Simply Cyber crowd might understand is what we actually mean by industrial control systems. And we a lot of people hear about it, but they're more used to the IT side. At least I think a lot of the crowd. So what is the kind of like the difference between IT and ICS or the OT environments? What do you think the differences are?
So, Don, great question. So the thing that separates your industrial control systems from your enterprise systems, we'll go over a few right now. Your industrial control systems bridge the physical world. So think about your things that make your process, your pumps, your valves, your different tanks, your temperature, pressure, level, flows, things like that. Your physical devices, it bridges them to the virtual world. So in the virtual world is where you have all your programming, you have all your analytics, it has your environments where you're telling your process what to do on your valve open so far, your pump to turn off and on is taking inputs from many different sensing devices, so temperature, flows, pressures, things like that. And then it's running through your program, and it's telling your valves to open and close, or your pumps to turn off and on, the breakers to open and close, things like that. The biggest thing that I always go back and tell people, difference between IT and OT, is health, life, and safety. So with industrial control systems, you got your health, life, and safety part. So you can hurt somebody, you can kill somebody, you can pollute the environment, you can create a really bad situation really quick. Unlike in your IT department, all important stuff. Never want to take anything away from them. But if your email server goes down for a couple minutes or so, could you lose money? Absolutely. To create chaos in the office, 100%. But things aren't going to blow up. Things are not going to go and create that big black smoke over there and pollute the environment and hurt people and things like that. So ICS, you're bridging the physical world into the virtual world, and your IT. We all know what that is. We touch it every day, from your Microsoft Word to your Google Workspace, the Instagram. So we're all touching those IT systems.
Yeah. So, I mean, one of the things that kind of amazed me about this industry was the fact that, there is such a huge difference between the IT and OT, but the industrial side, the control network, there's different ways to refer to it. it's based on a lot of the same technology, so it's easy to equate the same interactions, the same type of communications and support for the OT environment. But the operational requirements is usually what I refer to it as. It's different, meaning that it's kind of exactly what you were just talking about. We've got a set of operational requirements in our corporate environment that rely us. We want uptime. We want to be making money. We need to protect certain things like personally identifiable information and credit card data and so forth. We have those concerns out on the IT side, but on the OT side, it's the same type of technologies, but the operational requirements are different because of the things that you were discussing. We want to get data from the actual physical world, the sensors, the pumps, the motors that are turning on and off. We want to collect that data onto servers, into databases. But it's just a different operational idea and requirements for that implementation.
I absolutely, Don, your IT systems that they have a pretty stringent uptime, also, right? Your email, your web server, and things like that. But your OT environments, your ICS environments, when we engineer them and put them in, they're running 24/7, 365 for 15, 20 years. Yes, we have maintenance outages and downtime to, perform updates or to clean a process out or do some kind of other maintenance. But for the most part, these are running 24/7, 365 for years and years and years.
Yeah, there's so much to consider about that. Now, we've been using a couple of different terms, and while some of the crowd might understand those terms, there's going to be a lot of people that are just tuning in to learn some of those things. So we've talked about ICS, industrial control systems. We've also talked about OT, operational technologies. Now, the way that I think about ICS is those industrial control devices. It's pretty much everything within the control area, but it's more down at the process level, meaning when I said the word field device, and when we think about program logic controllers, the different types of controllers that are out there, to me, that's at the process level, and that's the ICS devices. But when we say OT, I think that OT is the more of the IT type based technologies, meaning that your network switches, your Microsoft operating systems, your databases and web servers, Active Directory. I think about the IT technologies that are helping to support the control network side. And so it would be like ICS is kind of embedded inside the OT, like OT is everything. The control environment, the plant environment, and then the ICS are the actual different processes. So, is that the way you talk about it? Because I do think there's a little disconnect in the community.
Don, there's definitely a disconnect. And, OT is a relatively new word, new marketing word that was made up. And, there's some different stories going back and forth on how that term got made up. But, nevertheless, it's still a new word. So the way I think about it is everything from a cloud-based technology all the way down to that instrument level. It's the technology that goes into it. And your ICS or your ERP or your, pick a system, it's just a subset of OT. So yeah, Don, I think that we're thinking along the same line here. Your operational technology is everything that makes up your plant process control, or your plant process, or your industrial control systems, that device that's actually in these pipes, on that power line, on that part of that process, making that.
Now, one of the things that I end up in a lot of conversation with is helping people understand some of the differences between our enterprise-based, the IT side, and the OT side. So when we're trying to control things, now you hit on it like at the very beginning when you started talking about safety, and it's definitely the consequences. And it's we talk about consequences a lot. And actually, when we're talking about risk and like findings during security assessments, we really start, whereas on the IT side, the consequences, the impacts there, our loss of data, loss of confidentiality for some data, downtimes, that downtime business impact. And all of those apply to the OT side. However, the consequences can get different from a safety perspective. I remember flipping one bit when I was on a piece of software. I was like, "Hey, what does this bit do?" And it started a motor, and I couldn't stop it. Fortunately, it was in a lab environment. So, what are your thoughts around the differences between IT and OT and consequences, and what people that are new to this should consider?
Great question there, Don. Both systems do have consequences. Both systems have devastating consequences. You go to the IT side, and you flip that bit like you did to that motor. You're probably not going to start a motor. However, you can take the website down, you can take your email server down, you can take your ERP system down, you can take a lot of systems down that are business critical that can have devastating effects on your company up into putting them out of business, severely harming them. But while those are real consequences, when you go over to the ICS side or the OT side, and you do the same thing, and you release hazardous chemicals in the air or on the ground, or you turn off the power to a certain building or area, or you end up mixing two different chemicals together, and you ruin that batch of stuff that your company is making. So on the OT side, we go back to health, life, and safety. We go back to you can hurt somebody, you can pollute the environment, you can blow something up. A little bit different consequences, but still they are extreme consequences. Or both sides hold extreme consequences for something.
Yeah, and what another interesting aspect around that is the different types of industries. Like, it's the same. We use the same type of equipment to control these different environments, but it's different from electrical to distribution to food and beverage to making paper or glue. I mean,
we do. You did, Don. You take the controllers that you use in any of those industries. You can use them across all of them that you said, and you take a look at the devices, and it just has analog in and analog out. It doesn't say glue manufacturing analog in, or it doesn't say water purification analog in. Your controller doesn't care. Your programs are the things that are going to change what happens based on those inputs and outputs. But you're right; it is very similar, not the same technology across all the verticals. You'll find different families of controllers. You'll find different families of everything, right? But at the end of the day, there's a lot of difference, or I'm sorry, there's a lot of similarities between all the hardware and the devices that are used.
Now, getting back to the helping people understand some of the differences between IT and OT. One of the first lessons that I learned was the life cycle, meaning that these devices are expected to last for a really long time. When I came into this industry, I was thinking about the laptops that were being assigned to me. I was thinking about the servers that were in the data center. Those rotated out, anywhere between 3 and 5 years because of updates. The new server operating systems were available, but it didn't run on the old hardware. But the life cycle is different in OT. Can you explain that a little bit?
The life cycle definitely is different. So when we install something in the field, we're installing it for 15 to 20 years of continuous operation. Crazy, isn't it? Because we're talking about laptops that are 3 to 5, but in the instrument or in the ICS world, we're talking 15 to 20, sometimes even longer. Sometimes you go shorter than that. The business needs change and upgrades happen based on product changes. But it's not uncommon to find something running for 15 to 20, possibly even more. We when I'm out for assessments now, we still find NT. You still find Windows 7. Uh, Anything in NT, occasionally you'll find it, and you're not that shocked. But it's out there. You can go also non-Windows operating systems. We talk about Windows a lot because they are, the most installed. But you'll find all different kinds of crazy old stuff out there.
Yeah, and that's one of the biggest lessons that I learned was when I was evaluating. I was testing a test environment, and for a new capacitor substation for one of our clients. And while I was in there, I looked at all of the model numbers for all of the pieces of equipment that were in there. And then I looked it up on the vendor's website, and everything was end of life, and this was, even though I was in the lab environment, the actual environment was built and they hadn't turned it on yet because they needed to do the testing that I was helping them to do. But everything matched, from the configuration to the actual devices that were in there to the software that was installed on the monitoring systems. And so I asked him, I said, hey, this is all end of life. What's going on there? And he was like, yes, they're end of life. And you can make the recommendation for us to get new ones if you want to. But when we got this approval for this process 5 years ago, they gave us a lump of money. We had to go to the public. We had to get the project approved. We got assigned a lump of money, and we bought everything at that moment. And it took us this long to build the pads and get all of the substation infrastructure in place, and work with the vendors and the integrators to get all of the wiring just right so that this capacitor substation will work. And it took us 5 years to get to this point, and now we're deploying it. So yes, everything is, if we wanted to update the device, we'd have to buy the new ones. And the consequence of that would be that we would have to redesign everything. We'd have to go through all of the wiring again. We'd have to call those contractors in to do all of the programming for everything again. And it would take us 5 years. We'd have to buy that now, and it would take us 5 years to actually implement it before even going live. So then everything else is end of life. So it's when we're talking about life cycle, that's one of the things I learned is like, it's this, it takes a long time to physically do all of this stuff correctly. And we can't just update. We have to come up with smarter ways to think about protecting these environments. They really put a lot of thought into the architecture to limit people getting there. I mean, that's one of my experiences.
Don, your experiences are the same as many others, right? So, to your point, when you build a plant, you build a substation, you build this stuff here, there's a lot more that goes into it than just your embedded device or your ICS device. There's you go across different manufacturers, there's different programming techniques, there's different programming software, there's different mounting, different wiring, things like that. So you just can't go and upgrade that device, even within the same family a lot of times, because, hey, the terminals 1 and 2 used to be power input, used to be, plus or minus 24 volts. Well, now they don't make this thing in 24 volts anymore. Now it's only in 110 volts AC. So now your wiring has to change. Well, now your cyber guy or your person putting it in, they may not be the person that wires it or does the drawings or updates, approvals and things like that. So it's a whole process. Unlike your laptop that you get, it's going to go to your IT department. They're going to install the image that they have. The image has been tested. The image has been gone through. Everybody's signed off on it. You get that computer, you're good to go. This year, we're involving technicians, engineering. We're involving IT. We're involving a lot of other groups to, install that updated device, open that port, network port. Maybe it's a different IP. There's a lot of things that go into upgrading things. That's why when people say the thing's old, just upgrade it. Well, could be a lot of effort. That's a lot of money, and a lot of times you don't need to upgrade it unless you're running into a supply chain problem where you're running into other problems, but upgrade isn't always the answer.
And it was funny. One of my at that location, one of my recommendations is that they didn't have door sensors on the cabinet doors. So if somebody was in there unauthorized access, they didn't know if they opened up the control cabinet or not. And while they had doors or they had cameras on the outside, they didn't have cameras on the inside. So if somebody didn't get in, you wouldn't know what they did. And sometimes people just get in to keep warm, get out of the weather and stuff like that. And so I was like, hey, what do you think about the recommendation of putting a door switch in there so you can tell whether or not it's opened or not? Door switches, I went out and I looked at SparkFun. It was like a $5 door switch. And my a point of contact, he was like, Don, you're absolutely right. That door switch is $5. But to implement that door switch in this area, it costs $60,000 just off the top of his head. And that's because he had to retest he had to figure out how to connect it into that controller. He had to determine whether or not they had the additional inputs and outputs. He didn't think they did. He thought he had used everything up, which meant a new controller module, which meant that they had to update all of the wiring diagrams. They had to test to ensure that that connectivity and that energy didn't have a negative impact on the rest of the environment and that they could do it. They had to also update all of the documentation that was spread out to all of that, and all of that testing and update $60,000 once they worked with that integrator and vendor. All for me just wanting to know whether a door was open or not.
Yeah, I got to say that these are big differences between IT and OT. You can upgrade usually easier. However, IT also has problems with upgrading. They also have problems with budgets. They also have problems with different resources and stuff like that. So it's not just the OT group that's the difficult group when it comes to upgrading and stuff. So I think that we just see it.
One of the things we talked about before is the difference between CapEx and OpEx. It took me a long time to understand that. What is the difference between CapEx and OpEx?
So capital expenditures versus operational expenditures. So think about your operational expenditures as labor, as in your fuel that's going to go to your building. It's your consumables that you need to operate, your consumable expenses that you need to operate your facility. For capital, that's going to be that steel, the concrete, the building, a physical device. So it could be your PLC, your DCS system, but it's physical things that do not include labor, that do not include your constant feeding.
So people are OpEx.
People are OpEx majority of the time.
Yeah, because that's kind of what it. When I was talking to Tim Conway, one of my mentors, that's what he brought up to me when we were talking about some of the challenges on the control network side. And I do think this is a challenge on the IT side as well. In other words, they don't allow us to hire everybody. But at the same time, the expectation in the control environments, and this is a bigger difference, I think, is they're willing to spend money to build things, right, and get things, and a part of acquiring those things is implementing them and deploying them. So I figure that all goes into that CapEx, capital expenditures, is the actual deployment of that. But once you shift out of that, now everything that's supporting that, to include cybersecurity, security assessments, monitoring, managed service providers, that all kind of shifts to the OpEx, where they're not really, spending money there. So, I mean, that's a challenge, right?
That certainly is a challenge, Don. And, we hear frequently, at the end of the year, or even when we're working on a project, is, make sure you include service in that quote up front, and, other things to include that operational expenditure that they would normally have built into the quote for CapEx. So people to install it or to run it, or program things like that, include those costs up front as part of the offering.
Yeah, so that's definitely a challenge. I'd say, hey, Tom, this is a great start. I think we've covered a lot of kind of like that starting, introduction into this field. We've talked about the differences between IT and OT. Some of the terminology, some of the basic terminologies that we're going to be using going forward. The difference, the consequences and life cycles and capex. There is so much more, and hopefully we can cover some of those things. It's we're getting pretty close on time, but if you had to say, another thing, like, what would you want somebody to walk away from this conversation with?
The Don, one of the things I think I'd want people to walk away with the conversation knowing is what's coming up in our future episodes. So I know that you and I, we sat down and planned out season 1. So why don't we give our listeners a little bit of sneak peek on what's coming up next in season?
Yeah, so I mean, we're definitely, some of the things that we're hoping to talk to a few people about. First, how do you get into this industry? What are some of the challenges and things that they should do? So getting into the whether it's OT, hopefully you can talk about that, but definitely from a cybersecurity side as well. Definitely, we haven't gone into the differences between critical infrastructure and things like food and beverage and so forth. I think that we can have some, and hopefully we can bring in some good people, maybe from the water sector, to help people understand some of those challenges. I mean, there's a lot going on there. One of the things I personally want people to understand, it's, because I think it's really important, both for operations, but also for cybersecurity, is the 5 ICS critical controls. Now, I mean, I'm a SANS instructor, and that did come from the SANS team. But at the same time, I use this on my day-to-days for my security assessments, the way I'm thinking and approaching doing cybersecurity, trying to simplify some of the concerns, like what we're trying to identify to help operations, rather than just doing cybersecurity stuff for cybersecurity. So that definitely we're going to talk about the 5 ICS critical controls soon. So,
Don and I'd have to agree with that. You and I were down in Tampa last week at the conference, and I talked about those 5 critical controls a lot. Why? Because people need to hear them. People are saying, "Where do I start?" And it's a great place to start. Does it fit everybody? Probably not, but you certainly can have a fantastic place to start, knowing where to start and a plan. So we're going to go over that stuff here.
Where can people find you when you're not right here?
When I'm not right here. So you can find me on social media, LinkedIn, and then through the ICS Village, we have our Slack channel. If you go to icsvillage.com, there's a link to join Slack. We are updating our website right now. So if you hear this and you go there and it's not there, just reach out on social media, whether it be X or LinkedIn, and or send an email to info@icsvillage.com, and we'll get you joined in the Slack. And then LinkedIn. So
yeah, LinkedIn, and it's the same for me. I mean, I've kind of gone away from a lot of the social media stuff. I'm pretty much exclusively on LinkedIn, so y'all can find me there. I'm on multiple Discord channels. I'm on the ICS Village Slack as well, so you can find us all there. So first of all, hey, great first episode, Tom. Thanks for joining me for this. I'm looking forward to our future conversations, and hopefully everybody has a great day. So thank you.
Thank you, everyone. Thank you, Don.